This is my third video lesson for Unit 15. In this lesson, we'll be analyzing properties and structures of hydrocarbons. Go to page 11 in the class packet. Learning target. At the end of the lesson, I'll be able to analyze properties and structure of different types of hydrocarbons. Homework is number 3, which will be a Junipod based off this lesson. There'll be a quiz Junipod on PowerPoints 1, 2, and 3. Hydrocarbon is defined as a compound with only hydrogen and carbon, so it's a mostly nonpolar molecule. On Table Q on your reference table, lists out 3 types of hydrocarbons: alkane, alkenes, and alkynes. Alkanes have a carbon-carbon single bond, alkenes have a carbon-carbon double bond, alkane have a carbon-carbon triple bonds. The general formula is used to identify what type of hydrocarbon you have. N stands for the number of carbon atoms. Here are 3 examples of each type of hydrocarbon. Ethane has 2 carbons. Using the general formula, the number of hydrogens is 2n plus 2, or 2 times 2 plus 2, which is 6. As you can see from the structural formula, there's only single bonds. Ethene also has 2 carbons, but it is an alkene because of the CC double bond. By using the general formula, N is equal to 2, so the number of hydrogens is 2 times 2, which is 4, as seen on the structural formula. Ethine also has 2 carbons and is considered an alkyne because of the carbon-carbon triple bond. By using the general formula, the number of hydrogens will be 2 times 2 minus 2 equal to 2. That's why there's 2 hydrogens in the structural formula. Hydrocarbons can either be saturated or unsaturated. Saturated hydrocarbons have only single bonds between the carbon atoms. Alkanes are considered saturated hydrocarbons. Unsaturated hydrocarbons must have at least one double or triple carbon-carbon bond. Alkenes and alkynes are considered unsaturated hydrocarbons. Here's a summary table of the information that can be extracted from Table Q, the homologous series of hydrocarbons. Let's start with alkanes. For the bonds found between carbon atoms, it is only single bonds. For the general formula, it is CnH2n plus 2. For the ending of the name, you have to look at the example. It is ANE or AIN. For the beginning of the name, the prefix is based off Table P. Table P is the organic prefixes. If you look at the structural formula, there is 2 carbons, so the prefix will be F. That is why this compound is known as ethane. For saturation, alkanes are saturated. For alkene, there must be at least one carbon-carbon double bond. For the general formula, if you look on Table Q, is CnH2n. For the ending of the name, if you look at the example, is ENE or ENE. For the beginning of the name, you gotta look at Table P, and the saturation is unsaturated. For alkynes, there must be at least one carbon-carbon triple bond. The general formula, if you look on Table Q, is CnH2n minus 2. The ending of the name, if you look at the example, is yne, Y-N-E. The beginning of the name, you have to look at Table P for the organic prefixes. For saturation, alkynes are unsaturated hydrocarbons. Keep in mind the general formula for alkene and alkyne is only for one multiple bond. For example, a molecule with 2 double bonds will not follow the general formula of CnH2n. Learning check number 1. Which formula represents an alkane? Pause the video, resume was completed. So you have to use Table Q. Alkane have a general formula of CnH2n plus 2, so the only one that fits it is choice 4, C3H8. N is 3 in this case. Learning check number 2. Which hydrocarbon is saturated? The only type of hydrocarbon that is saturated is alkane. So the answer is choice 4, C4H10, because it follows the alkane's general formula. Learning check number 3. Which structural formula represents a saturated hydrocarbon? Pause the video, resume as completed. Saturated is referring to alkane, which is carbon-carbon single bonds, so the answer is choice 1. Choice 2 is wrong because this is not a hydrocarbon. There is chlorine here. Learning check number 4. What is the name of the following substance? Pause the video, resume as completed. The first step is to identify what type of hydrocarbon this is. Since there's a triple bond, it is an alkyne. Next, we have to use table P to figure out the prefix. Since there's 4 carbons, it is but, so the answer is choice 3, butane. Learning check number 5. What is the name of the following hydrocarbon? Pause the video, resume as completed. The first step is to figure out what type of hydrocarbon this is. Since there's only carbon-carbon single bond, it is an alkane, so the suffix will be ane. To figure out the prefix, we have to use table P on the reference table. Since there's 5 carbons, the prefix is pent, so the name of this hydrocarbon is pentane, so the answer is choice 1. For practice number 2, complete the table using reference table P and Q, figure out the chemical formula, the type of hydrocarbon, the homologous series, and the name of the compound. Pause the video, resume once you complete it. Here are the answers. Cis-trans isomers exist because of the rigid nature of double bonds. If you recall from the previous lesson, double bonds cannot rotate. Cis isomer is when 2 groups that are attached to the carbons of the double bond are on the same side of the double bond. As you can see, the 2 groups are on the same side of the double bond. For trans isomer, the 2 groups are on opposite sides of the double bond. As you can see, the 2 groups are on opposite sides of the double bond. Both isomers have the same chemical formula, the same saturation, but have different properties. Now I want you to watch a video about hydrocarbons and cis-trans isomers. The link to the video will be in the descriptions. Once you watch the video, resume this one. In the video, it talked about different types of fatty acids, saturated, unsaturated, and trans. So here are some examples of these fatty acids. Which of these molecules do you predict to have a higher melting or boiling point, and why? You should know from previous unit, the boiling point and melting point is dependent on the strength of the intramolecular forces. So which of these will have stronger intramolecular forces? It is the trans isomer because it has more intramolecular forces, there's better stacking or surface area in comparison to the unsaturated and saturated fatty acids. Therefore, more energy is needed to break them. That is why trans fats are unhealthy. For question 2, why is unsaturated fats, the cis one, is healthier to eat than the saturated and trans fat? If you look at the structure, the unsaturated fat looks crooked. There's a kink. Therefore, it does not stack as well as the other fats. So more energy is needed to break the intramolecular forces of trans and saturated fats than cis unsaturated fats. So here are the melting points of each of the fats. Notice that unsaturated fats have the lowest melting point. So the reason why unsaturated fats are much healthier because it's much easier for the body to break down unsaturated fats than the other types. For practice number 3, identify if the following compounds have a cis or trans double bond. Pause the video, resume as completed. Here are the answers. This concludes the video lesson. Remember to do the Juniper homework and quiz.